We're going to continue looking at how to apply our properties of logarithms to solve logarithmic equations with these next two examples. In example 5, we have log base 3 of 64 minus log base 3 of 8/3 plus log base 3 of 2 minus log base 3 of 2 equals log base 3 of 4r minus log base 3 of 2. Now that is a long equation. So what are we going to do first? I'm going to look at this. There's a lot of stuff on the left side. And so right off the bat, I'm going to look, can I simplify anything? Well, I see log base 3 of 64 minus log base 3 of 8/3. Can't simplify anything there yet. But here, log base 3 of 2 minus log base 3 of 2. It's the same log, one positive, one negative. Adding, subtracting. Those cancel each other out right away. And so I really have the equation log base 3 of 64 minus log base 3 of 8/3 equals log base 3 of 4r minus log base 3 of 2. That's a lot simpler. So let's look at the left side. I am subtracting logs. That is like subtracting exponents, which means I'm going to be applying my quotient rule. So to combine these two logs together into one log, log base 3, I'm going to divide the expressions. I'm going to take 64 and divide by 8/3. On the right side, I am subtracting again, which again means I'm applying my quotient rule. So to combine these two expressions together, I am going to divide 4r by 2. And let's go from there. So if I am taking 64 divided by 8/3, I'm going to simplify that. Now I'm going to do it off to the side without a calculator to show you and to help you. When you are dividing by a fraction, think of it like you did when you first learned how to do it in elementary school. To divide by a fraction means you multiply by the reciprocal. So it's really 64 over 1 times 3 over 8. Now I'm going to simplify. I know 8 goes into 8 once, and 8 goes into 64 8 times. And so 8, left with 8 times 3, which is 24. And so really I have log base 3 of 24 equals log base 3. Well, 4r divided by 2 is 2r. So log base 3 of 24 equals log base 3 of 2r. You have one log all by itself on the left and one log of the same base on the right all by itself. So you can cross them out and solve. And so you get 24 equals 2r. Divide both sides by 2. R is 12. And if I were to plug 12 in to where the variable is, 4 times 12 is 48. It meets our definition of logarithms, and so we're good. So even though this was a long example, on the left side, we saw we could simplify right away by crossing out the log base 3 of 2, since there's one that's positive, one that's negative. And then we see our quotient rule on the left and our quotient rule on the right. Let's look at example 6. Log base 6 of x squared plus 2 plus log base 6 of 2 equals 2. Now this is interesting. I have two logs on the left that are being added. And so that is going to be my product rule. If I'm adding logs, it's like adding exponents, which is your product rule. So I'm taking log base 6 of the product of x squared plus 2 and 2. And the right side just stays the same because there is no log there. So really, I'm taking log base 6 of the quantity 2x squared plus 4 if I distribute. And that equals 2. So this is a good example because now we only have one log on a side. We don't have a log on the left side and a log on the right side. So we have to remember, how do we solve these types of examples? If you have just one log all by itself, you convert to exponent form. And it's been a while since we've dealt with an example like this, so that's really good that we have one. So what that means is if you have log base b, let's say of n equals p, your base becomes the base of the exponent, the p is the power, equals your value. So really what I have is 6 squared equals my value, 2x squared plus 4. So 6 squared is 36, so 36 equals 2x squared plus 4. Yes, I see a quadratic, however, I don't see a linear term. I just see an x squared by itself, so I know that means I can solve by getting the x squared by itself and then square rooting both sides. So I'm going to subtract 4. So 32 equals 2x squared. And then what I'm going to do is divide both sides by 2 and get 16 equals x squared. And then when I square root both sides, what I get is x equals plus or minus 4. I have to check my answers though. Here is the original expression. If I have x squared plus 2, if I plug in a positive 4, I get 16 plus 2, which is 18, which works. So we know the positive one works. If I plug in a negative 4, if I square negative 4, I get a positive 16 plus 2. That works. It's positive as well. And so both of these answers work and satisfy my definition of logarithms. So in this video, it was good to go over example number 6 because we had to recall how do we convert when we have one logarithm for solving to exponent form for this.